Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which constructs a complete binary tree from its linked list representation. First, let us take an example. We are given level order traversal. We take the first node as root and the next two nodes are left and right children of root. The idea is to do level order traversal of the partially built binary tree using queue and traverse the linked list at the same time. At every step, we take the parent node from queue, make next two nodes of linked list as children of the parent node and enqueue the next two nodes to the queue. Now, let us have a look at the algorithm. We have the linked list and we pass the head node of the linked list to convert list to binary function and root node. Note that we will be using a queue data structure. Since head is not null, we make root equal to head, so root will point to 10. Next, we push the root node into the queue. Hence, 10 will be enqueued. We make head point to heads next. Hence, head will point to 12. Since head is true, we enter the while loop. Now we take the parent node from the queue and remove it. So, parent will point to 10 and 10 will be popped from the queue. Next, we take next two nodes from the linked list. We will add them as children of the current parent node and push them into the queue so that they will be the parents to the future nodes. Hence, we take left child and right child variables and make them point to null. Now, left child will point to a new tree node which has data equal to head. So, left child will point to 12. Now we push the left child into the queue. So 12 will be enqueued. Next, we make head point to heads next. So head will point to 15, which is 12's next. Since head is true, we make the right child point to a new binary tree node which has data equal to head. So right child will point to 15. We enqueue the right child into the queue. Hence, 15 is enqueued. Now we make head point to heads next. So, head will point to 25. Next, we assign the left and right children of parent. Parent's left will point to left child which is 12. And parent's right will point to right child. Since head is not null, we continue with the while loop and now parent will point to the front node in the queue which is 12. We pop 12 from the queue. Now we make left child and right child null. Next, left child will point to a new node which has data equal to head. So left child will point to 25. And we push 25 into the queue. Next, we make head point to heads next. So, head will point to 30. Since head is true, right child will point to a new node which has data equal to head. So, right child will point to 30. Also, 30 will be enqueued. Now, we make head point to heads next. So, head will point to 36. We make parents left point to left child and parents right point to right child. Since head is not null, we continue with the while loop. And now parent will be 15 and 15 will be dequeued. We make left child and right child point to null. Left child will point to a new node which has data equal to head. So left child will point to 36. We enqueue 36 into the queue. Now we make head point to heads next. Since 36 does not have a next, head will point to null. Next, we make parents left point to left child and parents right point to right child. Since head is pointing to null, we come out of the while loop and we have the final tree. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.